All right. I hope that you've been able to find your way around the normal model and you've been able to solve for missing values and find probabilities. So we wanted to find probabilities, percents, proportion of observations. The three P's, we used norm CDF. Okay. And then if we needed to find a z-score or your x value or your um, mean that was missing or the standard deviation. So if you had three of those four things and you just needed to solve for the one missing item, we used our formula x minus the mean over the standard deviation equals z. Okay, but now we're just going to kind of, add a little bit more to our understanding of the normal model, a little bit of enrichment. So here we go. The two things that we're going to address are how to solve for both mean and standard deviation. So if we're given information that essentially sets up two locations on the normal model, two locations and two unknowns means we have a system of equations. And so we're going to make two equations, make that connection, and then solve and substitute in, like you would in your algebra classes with a system of equations. Here we go. All right. And then actually, then the other thing we're going to do is make that connection between box plots and the normal model. Make that connection there. Here we go. All right. So I have our steps written out. First, you got to draw a picture so you see what's happening. Okay. So I draw a normal model and then I fill in the blanks of what they tell me. Okay. So they say the lifespans of certain batteries are normally distributed. It is found that 15% of batteries last less than 30 hours. So that's going to give me, the percent's going to give me a z-score, and then the hours, the 30 hours is, of course, my x value. So look here. On my normal model, see, look, I got my z-score here of this lower 15% because it says less than 15%. So that's a z-score of negative 1.04. And the x value that corresponds with it is 30. So those two things, negative 1.04 z-score and x value of 30 months, are in the same location. All right, next location. 10% of batteries last more than 50 hours. So that's the top 10%, more than 50 hours. The top 10%, of course, has inverse norm of the area below is the z at that spot. So it has a z-score of 1.28, and its x value, its context at that location is 50. All right, so now here's what we got. So we drew out our facts on our normal model. We identified both locations of the z-scores and the x values. Now let's set the z-scores, distances, and the context distances equal to each other. So here we go. So z-scores first. 1.28 minus negative 1.04 is a distance of 2.32. So from the lower to the upper, this is 2.32 standard deviations wide. So I write 2.32 SDs. All right, but in context world, that equates to 20 months wide. So 2.32 standard deviations is 20 months wide. So then when I divide by 2.32, that means one standard deviation is 8.62 months wide. All right. So then once you have gotten solving for the standard deviation, now go substitute it back into one of your locations. Doesn't matter which one. Each location is an equation. So I usually pick the positive one if there's a difference in the positive and negative. So I got a z-score of negative 1.28, or I'm sorry, positive 1.28. And there's my x minus the mean over, and then there's that standard deviation that I just found a moment ago. Now, algebra and solve, and that gives me my mean of 38.97 months. So the batteries last an average of 38.97 months with a standard deviation of 8.62 months. All right, let you try this next one. So take a moment, because I just have two examples here. So take a moment and try that. Stop the video and try it. You also, the bonus on yesterday's assignment was one of these kinds of problems. So you could go try that problem as well and look at the key to yesterday's assignment and see how that was done. Okay, so if you would like another practice besides even this second one, so try the second one and then start the video again to check yourself. All right, here we go. We have 20% of pipes. Inverse norm of 0.20, that's a z-score negative 0.84 at this location, at the diameter of 9.667 inches. All right, 30, that was in words. Did you find it? 30% of pipes are above this 10.572. So that's the top 30%. So if that's the top 30%, then you're going to inverse norm the area below is the z at that spot. So then that is inverse norm of 0.70 to put this location 0.52, so about a half of a standard deviation above the mean. All right, next, let's now put our, let me see if I can pull it out. So now let's put our equations together. Find the distance for the standard deviations. The higher one, 0.52 minus negative 0.84. This is 1.36 standard deviations wide, because that's what your z-score tells us. And then inches, I just subtracted, and it's 0.911 inches wide. All right, so then I come up here and I set those equal. 1.36 standard deviations wide equals 0.91. So a standard deviation is only, it's 0.67 inches. Okay, remember, so this is a distance and it is context. Okay, so once you have your standard deviation, go solve for one of the missing, at one of the missing locations, or go solve at the equations, locations. So I'm going to take this top location right here. So here I am, z-score of 0.52, the x value of 10.578 minus the mean, and there's the standard deviation that I just got a moment ago. Algebraically solve, so the mean is 10.23 inches long, and the standard deviation is 0.67 inches long. All right, so there is solving for two unknowns. So I'm now going to stop this video. I like to do some of these ones that are shorter in two parts. So I'm going to stop it, and then I'm going to do the next video, which is about connecting together our box plot with our normal model. Okie dokie.